The world is cold enough to make survival feel like a negotiation with the sky. Across the late Pleistocene landscape, wind moves over open grasslands through broken woodland, across dry riverbeds and coastlines, where the sea does not sit exactly where it sits today. The planet is not frozen everywhere, not empty, not dead, but it is restless. Rain comes and disappears. Forests shrink, then return in fragments. Herds shift their paths. Lakes swell and vanish. In some places, dust hangs over the horizon like a warning. In others, the shore offers shellfish, fish, birds, and stranded pools of life to those who know how to read the tides. And somewhere inside this unstable world, small groups of Homo sapiens move carefully through the days, carrying firestone tools, children memories, and the fragile future of every human being who will ever live. There are no cities yet, no fields of grain, no walls, no temples, no written names. Humanity does not yet look like a force capable of reshaping a planet. It is not obvious that this species will endure, let alone dominate. A band of people may number only a few dozen. They know one another's faces, scars, skills, temperaments, and griefs. They know which roots can be eaten after roasting, which animal tracks are fresh, which waterholes fail in a dry year, which elders remember a safer valley, which children are strong enough to walk, and which must be carried. Their world is intimate, practical, dangerous, and vast. Beyond the next ridge may be food, strangers, predators, drought, or nothing at all. This is the strange beginning of the story, not a single dramatic moment when humanity stands at the edge and sees its own extinction, but a long narrowing, a pressure so deep that it may still be faintly visible in our genes. Around 72,000 years ago, give or take, the uncertainties that always surround deep-time humans may have passed through one of the most dangerous periods in our species' history. The popular version is simple and terrifying. A colossal volcanic eruption darkens the sky, the world cools, food chains collapse, and Homo sapiens nearly disappears. The real story is more complicated, more interesting, and in some ways more unsettling, because the evidence remains incomplete. Scholars still debate how close humans truly came to extinction, what caused the crisis, and whether one disaster can explain it at all. But what survives in the record suggests that our rise was never guaranteed. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. To imagine this ancient danger properly, it helps to remove the comfort of hindsight. Today, humans are everywhere. We live in deserts, forests, megacities, mountain valleys, islands, tundra, spacecraft, and research stations at the ends of the Earth. It is easy to assume that we were always adaptable, always destined to spread, always clever enough to survive whatever the planet threw at us. But 72,000 years ago, Homo sapiens is still a vulnerable African species, with uncertain footholds beyond its homeland. Some earlier expansions may have reached into the Near East or beyond, but they do not yet represent the unstoppable wave of later human settlement. The wider world is already occupied by other human lineages, including Neanderthals in Western Eurasia and Denisovans in parts of Asia. We are not alone, and we're not obviously superior in every way. We're one branch among several living through a time when branches can break. The human population is not one large connected nation. It is a scatter of groups separated by distance, climate, language, tradition, and the sheer difficulty of walking across a changing world. One drought can isolate a valley. One failed migration can erase a group. One generation of poor hunting disease or infant mortality can turn a living community into a vanished trace. There is no rescue from beyond the horizon, unless another group happens to exist nearby, and even then contact may bring conflict as easily as help. Survival depends on knowledge passed by voice and example, and when a small band dies, An entire library of local memory dies with it. That is one of the lesser-seen dangers of prehistory. Extinction does not always arrive as a spectacular ending. Sometimes it comes as silence spreading from camp to camp. A tool-making tradition stops appearing. A cave no longer receives ash from hearths. A coastline once used for gathering food is abandoned. Children who would have carried songs into the future are never born. The archaeological record sees only fragments, stone flakes, bones, charcoal pigments, shell beads, traces of meals, marks on ochre footprints hardened by accident. It does not easily show fear, hunger-failed births, arguments over whether to move, or the grief of leaving the dead behind. And yet those fragments matter. They tell us that early humans were not helpless. They made tools with planning and precision. They used fire not simply as warmth, but as technology, protection, and social center. They hunted, gathered, scavenged, trapped, collected shellfish, and learned landscapes with a patience modern people can barely imagine. Some groups used pigments perhaps for marking bodies, objects, or identities. Some made ornaments. Some carried materials over long distances, suggesting exchange travel or memory of far places. These are not primitive shadows waiting for history to begin. They are fully human people living before history learned how to write. Still being human was not enough to make survival certain. Intelligence does not fill an empty landscape with food. Fire does not stop a climate shift from changing rainfall. Stone tools do not guarantee that children survive a cold season. Even cooperation has limits when resources vanish. A species can be clever and still be rare. It can be flexible and still be trapped. That is why the idea of a bottleneck is so powerful. It suggests that at some point the human line narrowed to a smaller surviving population, perhaps not to a few individuals in the exaggerated sense sometimes repeated, but enough to leave a mark. The exact numbers are debated, the timing is debated, the cause is debated, but the possibility itself changes the way the human story feels. It means that behind all later empires, languages, voyages, machines, and cities, there may have been a period when the future depended on scattered fires staying lit. Picture one of those fires, not as a symbol, but as a working thing. It cracks in the dark, fed by wood gathered before sunset. Around it are sleeping children, sharpened stones, hides, baskets, bones cracked for marrow, perhaps shells from a distant shore, perhaps ochre stored for reasons both practical and meaningful. Beyond the light, animals move. The night is not empty. The people around the fire do not know they are ancestors of billions. They do not know that future scientists will study fragments of their DNA and argue over population sizes, volcanic ash, climate models, and migration routes. They know only the immediate arithmetic of survival: enough food, enough warmth, enough trust, enough luck. The mystery of 72,000 years ago begins there in that narrow glow. It begins with a species that has not yet conquered the world, living on a planet that is changing faster than any myth can explain. It begins with small groups holding knowledge in their bodies and voices, moving through landscapes that may reward them one year and punish them the next. And somewhere beyond their horizon, deep under an island in what is now Indonesia, pressure is building beneath a volcano large enough to disturb the planet itself. The human story is already difficult. The sky has not yet darkened. Long before the great volcanic shadow enters the story, the planet is already testing every living thing that depends on stability. The late Pleistocene is not a calm backdrop. It is a world of pulses, reversals, dry spells, wet returns, advancing cold, retreating warmth, and landscapes that refuse to stay fixed for long. Humans are born into this instability. They do not experience climate as numbers on a graph, but as the taste of dust in the mouth, the failure of a waterhole, The absence of familiar animals, the sudden greening of a plain after years of hunger, the dangerous promise of a valley that may not remain generous. The Earth around 72,000 years ago sits inside the wider rhythm of the Ice Age. Great sheets of ice cover enormous parts of the northern world, locking away water and lowering sea levels. Coastlines stretch farther outward than they do today. Islands are larger, shelves are exposed, and routes that will later drown under the sea lie open as dry land or marshy passage. But cold is only part of the story. Some regions become wetter, others become drier. Forests break apart into patches. Grasslands expand. Deserts breathe outward. Lakes appear like temporary miracles, then shrink into salt and cracked clay. The evidence remains incomplete because wind, water, and time destroy much of what once existed, but what survives in sediments, pollen lake cores, marine deposits, and ancient soils, suggests a planet in motion. For early humans, this motion is not abstract. A changing environment changes the map inside the mind. A route learned from grandparents may become useless if the river no longer runs. A hunting ground may empty if herds follow rainfall elsewhere. A cave may remain, but the plants around it may not. A coast may provide shellfish through one generation, and then shift as sea levels change, storms intensify, or resources are exhausted. People must remember experiment and move. They must gamble with incomplete information because waiting too long can be fatal, but leaving too early can be just as dangerous. This is one of the quiet pressures behind human survival, not merely the presence of hardship, but its unpredictability. Many animals are adapted to specific habitats, and when those habitats shift, they either track them, endure, or disappear. Humans are different in important ways. They can carry tools, they can carry fire, they can share food, they can teach children how to recognize distant signs. They can combine memory from older people with observation from younger ones. Yet even this flexibility has a cost. A highly social species depends on the survival of groups, not just individuals. A lone human may endure for a while, but the human future depends on communities large enough to reproduce, exchange, partners defend themselves and preserve knowledge. Across Africa, where Homo sapiens has its deepest roots, environments vary dramatically. Some regions offer coasts rich with marine life. Others hold savannas, woodlands, lakes, wetlands, mountains, and deserts that expand and contract with climate. This variety may have helped humans survive because when one zone failed, another might persist. But it also means that populations could become fragmented. Groups separated by deserts, dry corridors, mountains, or empty plains may lose contact. Over time, isolation can become genetic as well as cultural. A small group that survives apart from others carries only part of the species' diversity forward. If many groups vanish and only some remain, the future grows narrower. The phrase population bottleneck can sound clean, almost mechanical, but in lived reality it would be brutal and uneven. It does not mean every human everywhere experiences the same catastrophe in the same year. It may mean that over thousands of years, repeated stresses reduce numbers, break connections, and leave only certain refugees occupied. It may mean that many local populations disappear without the species as a whole vanishing. It may mean that some groups thrive temporarily, while others collapse beyond recovery. Scholars still debate the scale and timing, and no single explanation fully accounts for this. But the wider world of the late Pleistocene provides the stage on which such narrowing becomes possible. The animals around humans are also living through pressure. Large herbivores follow shifting vegetation. Predators follow them. Birds, fish, reptiles, insects, and small mammals respond to changing water and temperature in ways that ripple through food chains. A human group does not need the entire ecosystem to collapse in order to suffer. It only needs certain dependable foods to become unreliable. If shellfish beds decline, if tubers fail, if migrating animals arrive late, if edible seeds are scarce, if freshwater becomes contaminated or distant, then survival becomes harder. A community can absorb one bad season. Several bad seasons begin to change everything. There is a lesser-known truth about ancient resilience. Abundance can be dangerous if it teaches dependence. A group living near a rich lake or coast may become highly skilled at exploiting that place, but if the place changes, that specialization can become a trap. Another group living in a harsher, more variable region may already possess broader strategies moving between plants, animals, fish, shellfish roots, and stored knowledge of seasonal alternatives. What looks like poverty in the short term may become flexibility in the long term. What survives in the record suggests that early Homo sapiens were not locked into one way of life. Their strength lay partly in their ability to combine strategies to be hunters without being only hunters, gatherers without being only gatherers, coastal people in some places and inland travellers in others. Still, flexibility does not mean comfort. Imagine a band crossing an open landscape after rains have failed. They travel early before heat rises. Children walk when they can and are carried when they cannot. The old move with knowledge but not speed. Every stop must be judged. Is there water, shelter, fuel, danger, food enough to justify staying? A broken tool matters. A sprained ankle matters. A sick child changes the pace of the entire group. Decisions are made without maps, without certainty, without any way to know whether the next valley is better or worse. The world is wide, but not all of it is usable. At the same time, the sky itself is part of the uncertainty. Dust in the atmosphere shifts in monsoon patterns, changes in ocean circulation, and the slow machinery of glacial climate can transform rainfall across continents. In some periods, North Africa and the Sahara are greener, crossed by lakes, rivers, and animals. In others, they become barriers. Southern Africa may hold refugees along coasts and varied landscapes. East Africa, with its rift valleys, lakes, and highlands, may offer both opportunity and danger as water levels rise and fall. These regions are not simple stages where humans march forward. They are living puzzles, and the pieces keep moving. This unstable world matters because it makes the later disaster harder to isolate. When scientists ask whether a single eruption nearly wiped out humanity, they are not asking about a stable planet suddenly struck by one event. They are asking about a species already living under climatic stress, already fragmented, already dependent on local ecologies that could fail. The eruption, if it was decisive, may have been one blow among many, or it may have struck a population already weakened by older pressures, or perhaps the genetic bottleneck reflects long-term patterns rather than one dramatic year. The evidence does not settle easily into a simple story, but for the people alive, then none of these categories exist. They do not know Ice Age bottleneck climate variability or genetic diversity. They know cold mornings, dangerous crossings, empty traps, sudden plenty births, deaths, and the geography of memory. They know that the world can change. They know that survival belongs not to the strongest in any simple sense, but to those who can read change before change destroys them. And as pressure continues to gather under the earth, far to the east, humanity is already living close enough to the edge that one more disturbance may matter more than anyone around these ancient fires could ever imagine. Far to the east of the African landscapes where Homo sapiens is struggling through climate hunger and distance, the earth is preparing a violence no human being can understand. Under what is now the island of Sumatra, magma gathers beneath a volcanic system so immense that its final expression will not resemble an ordinary eruption. It will not be a mountain simply throwing fire into the sky. It will be a geological convulsion, a rupture large enough to leave behind one of the greatest volcanic scars on the planet. Today that scar is Lake Toba, a vast blue body of water resting inside a caldera so large that it is difficult to grasp from the ground. Its beauty hides the scale of what happened there. Around 74,000 years ago, though, the exact dating is refined and debated. Toba erupts with extraordinary force. Rock becomes ash. Gas punches upward into the atmosphere. The eruption column rises high enough to affect skies far beyond Southeast Asia. Pyroclastic flows devastate the surrounding region. The volcanic chamber partly empties, the ground collapses, and a caldera forms where the earth has fallen inward on itself. In terms of explosive output, the event belongs among the largest known eruptions of the Quaternary period. It is the kind of eruption that makes ordinary human language feel too small because it is not merely local destruction. It is a planetary disturbance. For a long time, this eruption has haunted the human story because of its timing. It appears close enough to the proposed human bottleneck to invite a dramatic possibility. Perhaps Toba did not merely devastate lands near the volcano, but pushed Homo sapiens toward extinction. The theory is stark. A super-eruption fills the atmosphere with ash and sulfur aerosols. Sunlight weakens, temperatures drop, rainfall patterns shift, plants suffer, animals decline, human populations already scattered and vulnerable crash. Only a small number of survivors endure in protected refuges, and all living people descend from those who made it through. It is a powerful story, and for obvious reasons it has travelled widely beyond scientific papers into documentaries, books, and popular imagination. But powerful stories are not always simple truths. Scholars still debate how severe Toba's effects were, how long they lasted, and how directly they affected human populations. Some evidence suggests the eruption was enormous enough to alter climate on a broad scale. Other evidence shows that human groups in some regions continued making tools and occupying landscapes through the period, which complicates any idea of a clean worldwide collapse. The evidence remains incomplete, and it does not allow us to say that Toba alone nearly erased humanity. Yet the eruption remains impossible to ignore, because even if it was not the single cause, it may have been one of the most severe environmental shocks our species ever lived through. To understand why Toba became so central, one must imagine not only the blast but the aftermath. Near the volcano, survival would have been nearly impossible across devastated zones. Ash would bury forests, rivers, and animal habitats. Hot flows could race over landscapes faster than anything alive could escape. But the greater mystery lies farther away, where the eruption's effects become less visible and harder to measure. Ash from Toba has been found across parts of South Asia and the Indian Ocean region, creating a thin but widespread signature. In some places, this ash layer becomes a time marker, a pale line in sediments that allows scientists to ask what changed before and after. Did plants vanish? Did animals decline? Did humans leave? Did tools stop appearing? Or did life continue with surprising resilience? One lesser-known detail is that volcanic ash is both destructive and scientifically generous. To the people who lived under it, ash could poison water, smother plants, irritate lungs, and turn familiar ground into an alien surface. To researchers, tens of thousands of years later, it becomes a timestamp. A layer of ash can link distant sites to the same event. It can sit between older and younger sediments like a page marker in the Earth's memory. This is one reason Toba remains so useful in debates about human prehistory. It gives scholars a rare global signal in a period where dates are often uncertain, scattered and difficult to compare. The eruption also forces a larger question about scale. Humans are used to thinking of disaster as something visible from where they stand: a storm, a flood, a fire, an enemy, a failed harvest. Toba belongs to a different order. Its danger may travel through air and climate, through sunlight and food chains, through seasons that become colder or drier, far from the volcano itself. A band of humans in Africa would never see the eruption. They would not know why rains changed, why plants failed, why nights sharpened, or why animals shifted. If Toba affected them, it would arrive as consequence without explanation. The cause would be hidden beyond any possible horizon. That hiddenness gives the story much of its power. Imagine people waking beneath a sky slightly dimmed by haze, or living through seasons where the old signs no longer behave. There is no word for sulfate aerosol. There is no concept of volcanic winter. There is only the practical terror of mismatch the season, when certain fruits should ripen but fewer appear. The migration that should arrive but comes thin. The cold that lingers. The water that tastes wrong after ashfall in regions close enough to receive it. The elders who search memory for a precedent and find none. No single day may announce the end. Instead, the world becomes less reliable. Yet it is important not to make the ancient people passive victims of a cosmic event. If humans survived Toba, they did so because they were already skilled at living with uncertainty. Some communities may have shifted diets, some may have moved, some may have leaned more heavily on coastal foods or underground plant resources. Some may have failed and their stories vanished. Others may have endured with little visible interruption. What survives in the record suggests a patchwork rather than a single global outcome. Toba may have darkened the sky, but it did not fall on one uniform humanity. It fell into a world of scattered groups, different habitats, different strategies, and different chances. That is why the Toba theory remains both compelling and contested. It offers a dramatic turning point, but the human past rarely behaves like a clean line. Genetic studies point toward ancient reductions in population size, but not all agree on their timing or severity. Archaeological sites show both disruption and continuity depending on where one looks. Climate models suggest serious cooling, but estimates vary. Some researchers see Toba as a near-extinction trigger. Others see it as an important eruption whose human impact has been overstated. No single explanation fully accounts for this, and that uncertainty is not a weakness of the story. It is the story. Lake Toba today is calm in a way that feels almost deceptive. Water fills the collapsed heart of the eruption. Green slopes rise around it. People live nearby. Boats cross the surface. The violence has become landscape. But beneath that calm lies a reminder that the human past was shaped not only by human choices, not only by tools and migrations and social bonds, but by the deep machinery of the planet itself. The Earth does not need to notice a species in order to threaten it. A pressure chamber under a distant island can alter the fate of people who never know it exists. And so the human line already thin enters the shadow of Toba. The crisis is not yet fully visible in bones or genes or ash layers. It must be reconstructed from fragments, from sediments, and models and arguments, from the stubborn survival of stone tools and the silent mathematics of DNA. But the possibility remains chilling, at a time when Homo sapiens is still rare, divided and vulnerable. The planet produces an eruption vast enough to test every fragile advantage humans possess. The sky changes, the land changes, and somewhere in the scattered camps of our ancestors, survival becomes even less certain. Ash does not fall like ordinary dust when it comes from a catastrophe of Toba's scale. Near the eruption, it can turn day into a choking grey confusion, burying leaves, branches, water nests, tracks, and the small signs by which animals know their world. Farther away it may arrive as a thinner veil, almost delicate in the geological record, but still carrying the memory of violence across enormous distances. A layer only a few centimeters thick can mean dead vegetation, contaminated streams, irritated lungs, damaged grazing grounds, and a season in which familiar food sources become strange. To living bodies, even a thin layer can matter. To the earth, it becomes a line. Before ash, after ash. The first and most obvious danger is local, and there the eruption is almost beyond survival. Around the volcanic center, pyroclastic flows race across the landscape, with heat gas and pulverized rock. Forests are flattened or burned. Valleys are smothered. Rivers are changed. The land itself is rewritten. But the human story depends on a wider question. What happens beyond the killing zone, beyond Sumatra, beyond the lands directly buried? This is where the mystery deepens, because Toba's greatest possible impact on humanity lies not only in ash that falls to the ground, but in material that rises into the sky and changes the behavior of climate. Large explosive eruptions can inject sulfur gases high into the stratosphere. There they form tiny reflective particles that scatter sunlight back into space. The result can be temporary cooling at the surface, sometimes called volcanic winter when severe enough. In modern history, smaller eruptions have produced noticeable global effects. Toba was vastly larger than those events, so it is reasonable to suspect that its climate impact may have been serious. But how serious, how long-lasting, and how unevenly distributed remain debated. Climate is not a simple switch. A volcanic eruption can cool one region sharply, while altering rainfall elsewhere, disrupting monsoons, shifting growing seasons and reshaping ecosystems in patterns that are difficult to reconstruct after 74,000 years. For early humans, the most dangerous change may not have been cold alone. Cold can kill directly, but ecological disruption kills more quietly. Plants respond first. Reduced sunlight and lower temperatures can slow growth. Ash can cover leaves and soil. Rainfall changes can damage flowering, fruiting, and seed production. Grazing animals then face thinner forage. Predators face fewer prey. Humans who depend on many parts of the food web feel the pressure from every direction. A group may still find water but less food near it. They may still find animals but fewer young animals in the herd. They may still recognize edible plants but harvest them at the wrong time because seasons have shifted. A lesser-known problem is that ash can create both short-term destruction and long-term fertility. Volcanic material can eventually enrich soils, but that benefit may arrive far too late for hungry people and animals living through the first months or years after eruption. The same substance that may feed forests centuries later can smother the plants people need now. This is a cruel rhythm of geological time. The Earth can recover beautifully from disasters that individual generations cannot survive. A landscape may become fertile after the people who knew it are gone. Across South Asia, where Toba ash is found at some archaeological and sedimentary sites, the question becomes especially tense. Did human communities living there disappear, decline, or continue? Some sites suggest continuity in stone tool traditions across the ash layer, meaning people may have survived locally or returned soon after. This does not prove life was easy. Continuity in tools can hide suffering, reduced numbers, or temporary abandonment, too brief to show clearly. But it challenges the most extreme version of the catastrophe, the one in which Toba simply wipes human presence from broad regions. What survives in the record suggests something more uneven, hardship in some places, resilience in others, and many gaps where evidence has been lost or never formed. In Africa, the effects are even harder to trace. The continent lies far from the eruption, and ash fall itself is not the main issue. If Toba matters there, it matters through climate. Cooler temperatures, altered rainfall, and ecological stress may have struck populations already living in fragmented habitats. But Africa is also vast and environmentally diverse. A disaster that harms one region may spare another. Coastal zones may remain productive when inland foraging declines. River systems may preserve life through dry periods. Highland areas may experience different patterns than lowlands. This diversity may be one reason humans endure. The world does not collapse everywhere in the same way at the same time. Still, even uneven disruption can shape a species. Imagine 3 neighbouring regions loosely connected by movement and exchange. One suffers drought and loss of game. Another remains livable but crowded as people and animals concentrate near water. A third is cut off by changing conditions. In such a world, survival does not depend only on whether food exists somewhere. It depends on whether people know where to find it, whether they can reach it, whether other groups already occupy it, and whether social ties allow entry rather than conflict. Environmental stress can turn geography into a series of closing doors. This matters because humans do not reproduce like insects or grasses. They cannot rebound instantly from a population crash. Children take years to mature. Mothers need support. Knowledge takes time to teach. A small group that loses too many skilled adults may still contain living people, but lose the ability to sustain itself across difficult seasons. A hunting method, a plant processing technique, a remembered route to water a way of making adhesive for stone tools, a tradition of reading tides or animal movement. All of this can vanish if the people who carry it die before passing it on. Extinction pressure is cultural as well as biological. The ski after Toba, if the volcanic winter models are even partly right, may have turned the ordinary difficulty of Pleistocene life into something sharper. Days may have grown cooler, seasons may have behaved oddly, rain may have failed in some places and intensified in others. In regions closer to ashfall surfaces may have been coated in pale grey, making landscapes look unfamiliar. Animals may have migrated unpredictably. The world would not need to become uninhabitable everywhere. It would only need to become unreliable enough for long enough that small human communities began to fail faster than they could recover. Yet the survival of Homo sapiens also suggests that catastrophe met flexibility. A species tied to a single food source, a single habitat or a single migration route might have been broken. Humans had more options, though never infinite ones. They could scavenge, they could gather shellfish, they could dig roots, they could share food beyond the immediate household, they could move knowledge through stories, gestures, imitation and teaching. They could remember past scarcity and prepare, at least in limited ways, for future scarcity. No single skill made them safe. Together these skills may have made enough difference. That phrase "enough difference" sits at the heart of the story. Survival does not require mastery over nature. It requires a margin, sometimes a narrow one, a few extra calories from shellfish, a remembered dry season water source, a fire kept alive through rain, a tool repaired rather than discarded. A child carried one more day until the group reaches food, a bond between bands that allows mates to be exchanged and knowledge to flow. These small margins do not look dramatic beside a super eruption, but they are how species pass through disasters. The ash of Toba, whether it caused a near extinction or only deepened an existing crisis, becomes a symbol of the planet's indifference. It marks a moment when geology enters biology, when the deep earth reaches into climate, and climate reaches into hunger, birth, movement, and death. The line of ash does not tell the whole story, but it gives the story a visible wound. Around that wound, scientists continue to argue because the human record is stubbornly partial. Some clues point toward catastrophe, others point toward resilience. Between them lies the most human possibility of all people suffered, adapted, moved, endured, and in some places disappeared without leaving enough behind to say exactly how. What follows from that is not certainty but a narrowing mystery. If humans did pass through a bottleneck, if our numbers fell and our diversity contracted, then the ash-filled sky is only one part of the explanation. The deeper question is how close the line came to breaking and why it did not. The idea that humanity nearly vanished does not begin with a single bone, a single cave, or a single layer of ash. It begins with something stranger and more intimate, the patterns hidden inside living people. Long after the camps are gone, after the fires have cooled, after the shorelines have shifted, and the ash has settled into sediment, DNA carries a faint memory of population history. It does not speak in scenes. It does not name the hungry seasons or show which groups failed, but it can preserve traces of expansion, isolation, mixing, and contraction. In that invisible record, scientists found one of the most unsettling clues in the human story. Modern humans appear to descend from a population that was once much smaller than it is now, and perhaps much smaller than one might expect for a species that would later cover the Earth. A population bottleneck is not the same as an apocalypse in the dramatic sense. It does not mean only 2 people survived. It does not require one mountain, one winter, or one sudden year of terror. It means that at some point the breeding population that contributed most strongly to later generations became reduced, limited, or filtered through a smaller number of surviving lineages. When that happens, genetic diversity can be lost. Rare variants disappear. Some lineages leave no descendants. Others become overrepresented simply because their carriers happen to survive and reproduce. The future becomes a narrowed version of the past. This is why bottlenecks matter. They are not only about how many people were alive, they are about how much variation passed forward. A species can contain many individuals but still lose diversity if populations are fragmented and only certain groups contribute to later expansions. Conversely, a severe local collapse might leave little trace if other populations remain large and connected. The mathematics is subtle, and scholars still debate how to interpret it in the human case. But the broad fact remains striking compared with many other widespread species. Humans carry relatively low genetic diversity. Something in our past narrowed the line. For a time, the Toba eruption seemed to offer a dramatic solution. The timing appeared close enough. The scale was large enough. The consequences were terrifying enough. Perhaps some argued volcanic winter reduced Homo sapiens to a few thousand breeding individuals, maybe fewer in popular retellings, and the entire later human story grew from that near disaster. The image is unforgettable. All future poets, farmers, kings, sailors, builders, children, and scientists descending from scattered survivors of a darkened world. It is no wonder the idea became famous, but fame is not proof. As genetic methods improved, the picture became more complicated. Different studies have suggested different timings and severities for ancient population reductions. Some signals may reflect long-term population structure in Africa rather than a single crash. If groups were separated for long periods, and only some later contributed strongly to populations outside Africa, the resulting genetic pattern could resemble a bottleneck without requiring one sudden extinction event. Other signals may relate to founder effects during later migrations, when small groups leaving Africa carried only a subset of African diversity into Eurasia and beyond. The evidence remains incomplete, and no single explanation fully accounts for this. This is one of the most important corrections to the popular story. The bottleneck may be real, but its meaning is debated. It may not have been one global moment when almost everyone died. It may have been a drawn-out narrowing caused by climate instability, isolation, shifting habitats, and repeated local losses. Toba may have contributed perhaps seriously, but it may not be the master key. In deep time, causes stack on top of one another. A drought weakens a population. A cold phase shrinks resources. A disease spreads through stressed groups. A volcanic event worsens conditions. A migration fails. A refuge survives. Later descendants make it look as if the whole species passed through a narrow gate, when in reality many gates closed and only a few remained open. To make sense of this, imagine human groups not as one lake rising and falling together, but as many small pools across a rough landscape. Some are connected by streams of movement and mating. Others are isolated. In wet periods, connections widen. In dry periods, they shrink. A disaster may empty some pools completely. Others persist in sheltered basins. Over thousands of years, the pools that remain connected to later expansions become the ancestors of future humanity, while many vanished groups leave little or no genetic trace. From the viewpoint of the present, it can look like a single narrowing. From the viewpoint of the lived experience, it may have been a mosaic of survival and disappearance. Archaeology complicates the story in its own way. If humans nearly vanished everywhere, one might expect widespread abandonment, broken cultural sequences, and silence after the eruption. Yet some sites show continuity. In parts of Africa and India, researchers have argued that tool traditions continued across the period associated with Toba. This does not eliminate hardship because people can endure disaster while still making similar tools, but it does challenge the simplest version of total collapse. What survives in the record suggests that Homo sapiens was battered by conditions in some regions, but not necessarily erased across its range. Another lesser-known issue is that genetic bottlenecks are easier to detect than to locate precisely in human experience. DNA can suggest that population size changed, but it does not automatically identify the weather, the landscape, the eruption, the disease, or the social breakdown behind that change. It is like seeing the narrowing of a river far downstream and trying to reconstruct every rock drought and landslide upstream. The signal is real, but the cause is not always visible. This is why the debate remains alive. The genes whisper that the past was narrow. The Earth records eruptions and climate shifts. The stones show survival in some places and absence in others. The challenge is fitting those records together without forcing them into a story too neat to be true. Still, the bottleneck mystery carries emotional weight because it brings deep time close to the body. The crisis is not only out there in ash layers and ancient lakes, it is inside us. Every living person carries DNA shaped by survival, loss, and chance. Entire human lineages once existed and left no descendants. Whole communities may have spoken, loved, invented, feared, and taught children only to vanish from the future completely. Their absence is part of our inheritance. We are not the descendants of everyone who lived. We are the descendants of those whose lines did not break. This changes the meaning of human success. Later, Homo sapiens will cross deserts, sail to islands, paint caves, bury the dead with care-shaped stone into blades, carve bone, invent agriculture, build cities, write laws, map stars, and argue about the past. But none of that future is visible from the bottleneck. At that point, survival may depend less on grand brilliance than on endurance, luck, local knowledge, and the ability to keep small groups alive through bad years. The human mind that will one day invent mathematics first has to solve the problem of tomorrow's food. The bottleneck also reminds us that extinction is not always the fate of the weak. Many vanished species were beautifully adapted to their worlds until their worlds changed. Many human lineages endured for hundreds of thousands of years before disappearing. Homo sapiens did not survive because the universe favored us. We survived because enough communities in enough places, under enough pressure, managed not to disappear. There is humility in that. There is also a kind of awe. So when scientists look at modern genomes and see signs of ancient narrowing, they are not finding a finished answer. They are finding the outline of a danger. The exact number of survivors remains debated. The timing remains debated. The cause remains debated. But the line itself seems thinner than comfort would like. Somewhere in the deep past, humanity passed through a filter. Some branches ended, some endured, and from the branches that endured came everything we now call human history. To understand what survival may have meant during the narrowing of the human line, the story has to shrink from volcanoes, climate systems, and genetic patterns down to the scale of footsteps. A small band moves through a landscape that does not promise anything. They are not wandering aimlessly. They carry maps made of memory where water sometimes waits beneath reeds, where stone good enough for tool-making can be struck from an outcrop, where certain trees fruit after rain, where predators den, where the coast bends into pools rich with shellfish, where another group may appear in a season of gathering. But memory is only useful when the world continues to resemble itself. In a time of stress, even old knowledge can become unreliable. A human band of this period may include infants, children, adolescents, skilled adults, injured adults, elders, and perhaps newcomers joined through exchange or marriage. Survival is not an individual contest. The group is a moving system of needs and abilities. A strong hunter who cannot share is dangerous. An elder who no longer walks quickly may still hold priceless knowledge of plants, water, weather, and old roots. A child is a burden in the short term, and the future in its most vulnerable form. Every decision carries weight because the margin is thin. Too much movement exhausts the weak. Too little movement traps everyone in a failing place. Food is never simply food. It is time, risk, knowledge, and luck converted into calories. A carcass found too late may be spoiled or guarded by predators. A herd may be visible but impossible to approach. Roots may be edible only after processing, and the difference between nourishment and poison may depend on learned steps. Seeds may require grinding or pounding. Shellfish may be abundant at one tide and unreachable at another. Honey may be worth the danger. Bird eggs may feed children for a day. Marrow inside bones may become precious when meat is scarce. What survives in the record suggests that early humans used wide diets where possible, but the record rarely captures the full labor behind a meal. In hard times, hunger does not always arrive as sudden starvation. It begins by changing the body quietly. People walk slower, wounds heal poorly, milk may fail, pregnancies become more dangerous, children become less resilient to cold infection and exhaustion. Decisions sharpen. A group may take risks it would once avoid approaching dangerous animals entering disputed territory, eating marginal foods, traveling farther between water sources. These choices can save lives or destroy them. No single explanation fully accounts for survival or collapse, because every group faces a slightly different balance of danger. Isolation is another threat. Small bands need contact with others not constantly but often enough to exchange mates' information materials and perhaps ritual obligations or alliances. If climate stress opens distance between groups, the biological and social consequences can be severe. A community that becomes too isolated may survive for several generations yet slowly lose options. Marriage partners become fewer. Conflicts become harder to resolve. Knowledge from other landscapes stops arriving. Innovations spread more slowly. In genetic terms, isolation can narrow diversity. In human terms, it can make the horizon feel empty. And yet, isolation is not always complete. One of the surprising strengths of Homo sapiens may have been the ability to maintain social worlds larger than the camp itself. A person may know people beyond the immediate band relatives in another valley, remembered partners near the coast groups encountered during seasonal gatherings. Objects can carry signs of connection. A shell found far inland, a particular stone transported from a distant source pigment, carried across a landscape. These things suggest movement memory or exchange. The evidence remains incomplete, but it hints that early humans may have built networks that help them endure environmental shocks. The camp itself is a place of labour, not merely rest. Stone is struck into flakes. Edges are retouched. Wood is shaped. Hides may be scraped. Plant fibres may be twisted. Fires are tended carefully because making fire may not always be easy, and keeping it alive can matter as much as lighting it. Food is divided, cooked, softened, or dried when possible. Children watch constantly. Learning is not formal, but it is relentless. A young person learns by imitation, correction, and repeated failure. How to hold a stone, how to read tracks, how to notice birds gathering near water, how to dig without breaking a tuber, how to stay silent when animals are near. Culture lives in these gestures. This is one of the great hidden facts of human survival. Knowledge must be reproduced every generation or it dies. Tools do not make themselves. Fire does not teach itself. A coastline full of food is useless to those who cannot read it. A plant resource is invisible to those who do not know when and how to harvest it. During a bottleneck, the loss of people can become the loss of techniques. If too many skilled adults die, the group may retain bodies but lose competence. If children survive without teachers, the future weakens. The biological line and the cultural line are braided together. There is also fear, though it leaves almost no trace. Fear of strangers when resources are low, fear of predators at night, fear of illness spreading through a close group, fear of the season failing again, fear of leaving a known place for an unknown one. But fear is not the same as helplessness. People who live in dangerous worlds often develop calm forms of courage. They do what must be done because no other option exists. They carry children, they repair tools, they follow tracks, they bury or leave their dead according to customs we may never recover. They wake again. The human body itself is part of the survival strategy. It can walk long distances, it can sweat efficiently, it can carry loads. Human hands can make and repair. Human infants are demanding, but human adults cooperate in raising them. This shared care may have been crucial. A mother alone under severe stress is vulnerable. A community that helps feed, protect, and teach children gives those children a better chance. Scholars still debate how far back particular forms of social care and symbolic life extend. But the broader pattern is clear enough. Humans survive through groups, and groups survive through obligations. Under a dimmed or unstable sky, the smallest acts become historical. A group chooses to remain near a coast instead of moving inland. Another follows a river farther than usual. Another joins with relatives after a failed season. Another disappears. These decisions do not announce themselves as turning points, yet over time they determine which lineages continue. The future of humanity is not held by heroes in any simple sense. It is held by tired people making practical choices with incomplete knowledge. The bottleneck, if it pressed as deeply as some evidence suggests, would have turned ordinary fragility into evolutionary consequence. A band that survived did more than protect itself. It preserved a strand of humanity's genetic and cultural inheritance. A band that failed may have taken with it unique songs, tool habits, plant knowledge, stories of landscape and genetic lineages that will never reappear. The tragedy is almost invisible because the dead leave so little. The triumph is equally quiet because the survivors did not know they were preserving the species. So the story of near extinction is not only a story of a volcano or a climate crisis, it is the story of small fires in large darkness. It is people waking before dawn, checking the wind, judging whether to move, sharing food that is not enough teaching children, because the future still demands teaching even when the present is harsh. Somewhere in those bands, in the breath between hunger and endurance, the human line continues. Not confidently, not inevitably, but enough. If the human line narrows, it does not narrow evenly across the world. Some landscapes become traps, others become shelters. In deep prehistory, survival often depends less on strength than on being in the right kind of place when the wider world begins to fail. A refuge does not need to be comfortable. It only needs to be reliable enough, varied enough, and forgiving enough to keep people alive through seasons that destroy less fortunate groups. Across Africa, the oldest homeland of Homo sapiens, such refuges may have existed in scattered pockets along coasts near rivers, around wetlands in highlands beside lakes, and in regions where different ecosystems meet. Africa is not one environment. It is a continent of immense variety, and that variety may be one reason humanity endures. When deserts expand in one region, forests may persist elsewhere. When open grasslands dry, a coast may continue to offer shellfish and fish. When a lake shrinks nearby, wetlands may still hold birds, reeds, fish, and edible plants. When lowlands become harsh highlands may catch moisture and hold cooler, more stable habitats. The evidence remains incomplete because many ancient coastlines are now drowned and many traces of human occupation have been erased. But what survives in the record suggests that humans did not survive in a single cradle. They survived through a patchwork of places. The southern African coast is one of the most important parts of this story. Their caves and rock shelters preserve traces of early human behavior through periods of climatic stress. The sea, when accessible, provides resources that do not behave exactly like inland herds or seasonal fruits. Shellfish cling to rocks, tidal pools trap life, seabirds nest, fish seals and stranded marine animals may become available to people with the right knowledge. Coastal foraging is not effortless, but it can be dependable in ways that inland hunting is not. A person who understands tides may read the shore as a living calendar. This coastal possibility matters because shellfish leave durable evidence. Shells can pile up in archaeological deposits, surviving where soft plants and wooden tools vanish. They show that some early humans were using marine resources long before agriculture, cities, or written history. That may sound simple, but it reveals a sophisticated relationship with the environment. The shore can be dangerous. Waves, sharp rocks, tides, and weather punish mistakes. Some shellfish are best gathered at certain times. Some coastal foods require processing. A group that lives partly from the sea must understand timing, place, and risk. This is not desperation alone. It is knowledge. Rivers and wetlands offer another kind of refuge. In dry landscapes, water concentrates life. Animals come to drink. Plants grow along banks. Fish, turtles, birds, eggs. Reeds and edible roots may cluster in places where surrounding land is poor. But water also attracts predators and other humans. A river refuge can feed a group while also drawing competition. It can become a corridor for movement or a boundary between strangers. Its value depends on social navigation as much as ecology. A rich place is not automatically safe if everyone needs it. Highlands may have offered different protections. Higher terrain can catch rainfall, preserve cooler microclimates, and hold plant communities unlike those in surrounding lowlands. Valleys within mountains can become pockets of relative stability. Caves and rock shelters provide protection from weather-preserved hearths and sometimes become long-term places of return. Such refugees are not isolated from danger, but they may buffer populations against the worst swings of climate. In a period when the wider landscape is unstable, even a modest buffer can matter. One lesser-known feature of refuges is that edges are often more useful than centres. Places where coast meets plain river meets savanna, woodland meets grassland, or highland meets lowland can offer multiple food sources within reach. Ecologists call these transition zones rich in opportunity, and for humans they may have been especially valuable. A group living near an environmental edge can shift its focus as conditions change. If hunting is poor, gather plants. If plants fail, search the shore. If the coast is dangerous, move inland temporarily. Flexibility becomes geographic. This may help explain why some human populations survived while others vanished. A band trapped deep in an increasingly dry interior may face fewer options. A band near a varied refuge may adjust without abandoning everything it knows. The difference between extinction and survival may be a day's walk to another food source. It may be knowledge of a hidden spring. It may be a seasonal gathering place where groups exchange information after years apart. What survives in the record suggests that refugees were not simply shelters from climate. They were engines of continuity. But refugees also change the human story in another way. They can preserve populations yet isolate them. If groups crowd into favourable zones while surrounding areas become empty, contact between refugees may weaken. People survive, but the species becomes fragmented. Genetic diversity may narrow. Cultural traditions may diverge. Small populations may become intensely local, shaped by the specific demands of the coast, the river, or the highland valley. Later, when climates improve and people expand again, only some of these refugee populations may contribute strongly to future humanity. Others may fade, merge, or vanish without clear trace. The idea of African refuges challenges the older image of one simple human origin point. Homo sapiens likely emerged through a complex process across parts of Africa, with populations sometimes connected and sometimes separated. By 72,000 years ago, humans are not a single uniform people waiting in one valley. They are distributed across varied landscapes, carrying different traditions and adaptations. Scholars still debate the details because fossils and archaeological sites are scattered and unevenly preserved. But the broader picture is becoming more braided. Humanity's roots are deep, regional, and interconnected. In these refugees, life is still hard. A coast does not remove hunger. A river does not prevent disease. A cave does not guarantee safety. People must still gather fuel, protect children, avoid predators, manage conflict, and endure loss. But refuge landscapes provide something priceless: repeated chances. A group that fails to find game can gather shellfish. A dry year can be survived with roots and fish. A storm can be waited out in shelter. An old route can lead to another valley. Survival often depends not on abundance every day, but on enough alternatives across bad seasons. Imagine a coastal shelter during a difficult period. Outside, the wind carries salt and dust. The sea is lower than today, exposing stretches of shelf now drowned. People move between the shelter and the shore, returning with shells, fish bones, seaweed, perhaps driftwood, perhaps stone from known sources. Children learn the rhythm of tides before they understand any larger world. Elders remember inland routes that are no longer safe every year, but may still matter when rains return. The group's survival is not heroic in appearance. It is repetitive, skilled, watchful, and deeply local. If volcanic winter or climate stress reached these places, it may have hurt them less than harsher inland zones. or it may have changed them in unexpected ways. Cooler waters, altered storms, shifting animal patterns, and changing rainfall could still bring danger. No refuge is immune, but some places bend without breaking. That may be the key. The human future may have depended on landscapes that could bend, and on people who knew how to bend with them. Africa's hidden refuges are therefore not side details in the near-extinction story. They may be the reason there is a story at all. When the larger world becomes unreliable, survival gathers in pockets. Around fires in caves, along tidal flats beside rivers, thick with reeds in highland valleys where mist lingers, small human groups continue. They do not know that elsewhere other fires are going out. They do not know that their descendants may one day carry their genetic inheritance across continents. They know only that the place still gives enough if read carefully, and so the line does not break. It thins perhaps, it fragments, it passes through hunger, ash, cold, drought and distance. But somewhere in refuges hidden by geography and later erased by time, people find ways to remain. The future of humanity is not saved in one grand sanctuary. It is saved in scattered edges of the world wherever land and water, memory and skill, chance and endurance meet. At the edge of survival, food becomes more than nourishment. It becomes strategy, memory and imagination. The humans who endure the dangerous narrowing of the deep past are not simply the ones who hunt best or travel farthest. They are the ones who can see food where others might see mudstone, thorn-tied shell, bone-bitter roots or a patch of ordinary-looking ground. In a world of unstable climates and uncertain herds, the ability to widen the meaning of food may be one of the quiet reasons Homo sapiens continues when so many lines in the past do not. The coast is one of the clearest examples. To modernize, shellfish may seem like a modest resource compared with large game. But for a small human group living through scarcity, shellfish can be extraordinary. They do not run away. They gather in predictable places. They can be collected by children, adults, and elders. They require knowledge of tides and safe harvesting, but not always the extreme danger of bringing down a large animal. In difficult seasons, that predictability matters. A few hours on the rocks at low tide can mean food enough to carry a group through another day. It is not glamorous survival. It is better than glamorous. It works. Shellfish also preserve well in the archaeological record, which gives them an importance beyond their ancient calories. Shell middens and cave deposits show that some early humans made repeated use of coastal resources, returning again and again to places where the sea provided. But the evidence remains incomplete, especially because many Ice Age coastlines now lie underwater. During glacial periods, sea levels were lower, sometimes far lower, which means some of the richest ancient shorelines are drowned beyond easy recovery. A great deal of the story may be resting beneath modern waves erased from ordinary sight. What survives in the record may be only the inland edge of a much larger coastal world. Food from the edge also includes rivers, lakes, marshes, and seasonal wetlands. Fish can be trapped or caught in shallow pools. Birds can be taken at nesting sites. Eggs can be gathered. Turtles, frogs, reeds, water plants, and roots may provide calories when open plains are poor. Wetlands are messy, dangerous, insect-filled, predator-haunted places, but they are also productive. A dry grassland may look wide and promising while giving little. A muddy wetland may look difficult while hiding abundance. Humans who understand these environments gain options when the larger climate turns against them. Underground foods may have been especially important, though they often vanish from the record. Tubers, bulbs, roots, and rhizomes can survive below the surface, even when above-ground vegetation looks poor. Some are toxic unless processed. Some require roasting, soaking, pounding, or careful selection. Some are seasonal. To use them well requires patient knowledge, often gathered and transmitted across generations. This kind of food rarely produces dramatic archaeological evidence, but it may have saved lives. The absence of preserved roots does not mean the absence of root gathering. It means the earth keeps some histories poorly. Seeds, nuts, and grasses add another layer. Long before farming, humans knew how to gather plant foods in seasonal pulses. Seeds can be eaten fresh, pounded ground, roasted, or stored briefly under the right conditions. They may not look impressive beside a large animal carcass, but they can support steady survival. The processing may be laborious. A handful of edible seeds can represent hours of collection. Yet this labour spreads risk. When hunting fails, plant knowledge matters. When plants fail, fishing matters. When fishing fails, scavenging matters. A wide diet is not a sign of weakness. It is insurance. Bone itself becomes food when times are hard, and this is another detail that can feel small until one imagines the hunger behind it. Marrow locked inside bones is rich and valuable. Fat is precious in many hunter-gatherer diets, especially where lean meat alone cannot sustain health. Cracking bones requires tools, effort, and timing. A carcass abandoned by predators may still hold calories for people skilled enough to extract what remains. Scavenging is not shameful in deep prehistory. It is intelligent opportunism. Humans survive partly because they are willing to use what the world leaves behind. Fire transforms this entire food landscape. It softens roots, makes some foods safer, extends the value of meat, helps process tough plants, and creates warmth around which food can be shared and knowledge transmitted. Cooking does not merely improve taste, it changes energy. Foods that are difficult or dangerous raw may become usable. Chewing time decreases. Digestion improves. Children and elders may eat foods they otherwise could not. In a crisis, the control of fire is not a decorative human achievement, it is a survival multiplier. Yet food is never only ecological, it is social. A large carcass, a rich shellfish harvest, or a patch of ripe plant food creates questions: who eats first, who carries, who shares, who is owed, who is remembered later. Cooperation can turn unpredictable resources into group survival. If one person gathers roots, another watches children. If hunters fail, gatherers may sustain them. If elders know a famine food, younger adults provide strength to dig it. A band survives by distributing risk across many hands. Scholars still debate the details of early social organization, but the basic principle is difficult to avoid. Humans are adapted not just to find food, but to share information about food. One surprising detail is that marginal foods may become central during crises. A bitter plant that no one prefers in good times may be life-saving when roasted correctly. Small shellfish may not be worth the effort during abundance, but become essential during scarcity. Insects, larvae gums, seaweed, small reptiles and trapped animals may enter the diet more heavily when preferred foods decline. The archaeological record naturally favours hard remains like bone and shell, so it can underrepresent these flexible, less visible choices. The true menu of survival was almost certainly broader than the evidence can show. This matters for the near-extinction debate because a species with a narrow diet is easier to break. If Homo sapiens had depended mostly on large-game climate disruption, could have been even more devastating. But humans are dietary generalists with cultural memory. They do not merely eat what instinct dictates. They learn, test, teach, remember, and revise. One group's survival trick can spread to another. A food once used only in desperation can become part of seasonal routine. Knowledge turns landscape into possibility. Still, flexibility does not erase suffering. A broad diet may prevent extinction while still leaving people hungry, thin, and vulnerable. Shellfish can sustain, but not always enough. Roots can fill the stomach, but gathering them can exhaust the body. Fish can be abundant, then vanish with water changes. Sharing can support the weak, but only if there is something to share. No single strategy fully accounts for survival. The human advantage lies in combinations, and combinations can fail under enough pressure. Imagine again a small group near an ancient shore. The inland hunting has been poor. The wind is colder than it should be. The old people speak of seasons that once behaved differently. At low tide, figures move across black rocks, prying shells loose, cutting feet watching the water. Children carry small baskets. Someone keeps fire alive above the beach. The meal that evening is not a feast. It is shells, cracked open roots, softened in embers, perhaps marrow from old bones, perhaps seeds pounded with stone. It is enough, and enough is the difference between a lineage ending and a child waking tomorrow. Food from the edge is therefore one of the great hidden forces in the human story, not the grand hunt alone, not the dramatic kill painted in modern imagination, but the patient harvest of small things, the willingness to eat widely, the memory of difficult foods, the reading of tides, mud reeds, stones and seasons. Humanity may have passed through its narrowest danger, not because it conquered nature, but because it learned to notice what nature offered in overlooked places. And as the crisis deepens, these overlooked places become more than landscapes. They become archives of survival written in shells, charred seeds, cracked bones, worn stones, and missing evidence beneath the sea. The human future may have rested not on abundance, but on flexibility, on people who could turn the edge of the world into a table however sparse, and keep eating long enough for the darkness to pass. The tools that stand between humans and extinction are not impressive at first glance. A chipped stone, a sharpened flake, a wooden shaft, a hearth, a hide scraped clean, a shelter placed out of the wind. These are small things beside a changing climate or a sky dimmed by volcanic ash. They do not stop drought. They do not command herds to return. They do not make a dying child well by themselves. Yet in the deep past, survival often depends on small things used well repeated patiently and taught before they are forgotten. Technology begins not as triumph but as margin. Stone tools are the most visible part of this ancient survival system, because stone endures when almost everything else disappears. Wood rots, fibre decays, skin sinew bark baskets, nets and cord usually vanish, unless preserved by rare conditions. Stone remains, and so it can mislead us into thinking. Prehistoric technology was made mostly of stone. In reality, the stone flake may have been only one part of a larger toolkit. It cuts meat shapes, wood scrapes, hide works, bone trims, plant fibres, and repairs other tools that the record has lost. The stone survives as the hard edge of a much softer world. By 72,000 years ago, Homo sapiens is already capable of sophisticated toolmaking in parts of Africa. Some communities produce prepared core technologies shaping stone in planned ways, so flakes come off with useful forms. This requires foresight. The maker must imagine the future shape inside the raw material before the final flake exists. It is not random smashing. It is controlled fracture, learned through practice, and probably taught through demonstration. A good toolmaker understands angles, force, grain, flaws, and purpose. One wrong strike can ruin valuable stone carried from far away. That detail matters because planning is survival. In a dangerous period, a tool is not only an object for the present meal, it is preparation for uncertain work ahead. A sharp flake carried across a landscape can become a hunting aid, a butchering knife, a scraper, a repair tool, or a means of making something else. A group that maintains tools well wastes less effort. A group that knows where good stone lies can plan routes around it. A group that teaches children to recognize workable material protects future competence. What survives in the record suggests that early humans were not merely reacting to the world, they were anticipating it. Fire may be even more important, though it leaves a more fragile record. Around a hearth, the human world changes. Fire extends the day. It warms bodies in cold seasons. It deters some predators. It hardens wooden points. It makes food safer and easier to digest. It creates a social center where knowledge can be transmitted during darkness. Fire is not simply a tool, it is a place. It gathers people, organizes labor, and turns night from pure danger into a space where memory can live. The control of fire is also a form of ecological power, but a modest and vulnerable one. Fire must be fed, fuel must be gathered, embers must be protected from rain and wind. In some environments, wood is scarce. In others, dry fuel is seasonal. A group may carry embers rather than risk losing flame. The evidence remains incomplete, and scholars still debate the details of fire use in different regions and periods, but by this stage, fire is deeply woven into human life. Losing it during cold hunger or wet weather could be disastrous. Keeping it alive is an act of care. Clothing and shelter are harder to see archaeologically, yet they may have made expansion and survival possible. Human skin is not fur. Humans can endure heat well, but cold wind and wet conditions punish exposed bodies. Hides, furs, plant fibers, and simple coverings could protect against weather insects and injury. Scrapers found in archaeological sites may suggest hide working, though interpretation must be careful. Needles become clearer later in the record, but clothing need not begin with fine tailoring. Draped hides, tied skins, woven plant matter, and temporary coverings may have existed long before they leave obvious traces. Shelter is equally varied. A cave can protect from rain and wind, but caves are not everywhere, and they may also attract predators. Rock shelters provide shade and refuge. In open landscapes, humans may use windbreaks, branches, hides, brush, or natural features. The best shelter is not always the most permanent. Mobile people need structures that fit movement. A temporary camp can be exactly what survival requires, close enough to water, high enough to avoid flooding, hidden, enough from danger, open enough for watching the horizon, supplied with fuel and raw material. The intelligence lies in placement. Adhesives are one of the lesser-known marvels of early technology. To attach a stone point or flake to a handle, humans may use plant resins, gums, ochre mixtures, sinew, or other binding materials depending on region and period. Producing compound tools requires more than a sharp edge. It requires combining materials with different properties, stone, wood, fiber, glue binding. Some adhesives need heating, mixing, or careful preparation. A hafted tool is a small engineering system. If it fails during a hunt, the failure can cost food or life. If it holds, it extends human reach. This ability to combine materials reveals something deeper about the human mind. A stone alone cuts. A stick alone reaches. Bound together, they become something neither could be separately. That mental leap repeated across countless small inventions gives Homo sapiens an advantage in unstable environments. Not invincibility, but adaptability. A tool can be modified for a new prey animal, a new plant, a new climate, a new landscape. Technology lets humans carry solutions from one place to another, but tools do not guarantee survival unless knowledge survives with them. A child can pick up a stone flake, but that does not mean the child knows how to make one, maintain one, or use one safely. Skills require teaching, attention, and repeated practice. During a population bottleneck, the danger is not only that people die, it is that teaching chains break. If too few experts remain, if children are orphaned, if groups become too small, technological traditions can weaken. In this sense, every tool is also a social artifact. It carries the hands of those who taught its making. The archaeological record sometimes shows changes in tool traditions, and these changes are difficult to interpret. A new style may reflect innovation, migration, adaptation to different resources, or simply the survival of one tradition over another. A disappearance may mean abandonment, population loss, change behavior, or poor preservation. No single explanation fully accounts for every pattern. But the persistence of human tool-making through harsh periods shows that technology remained one of the main ways people negotiated with danger. Tools also shape time. Without a sharp edge, processing a carcass takes longer. Without fire, digesting certain foods costs more energy. Without containers or carrying devices, movement becomes harder. Without scrapers, hides are less useful. Without weapons, hunting and defense become riskier. Technology compresses labor, and in survival conditions, saved time is saved life. A group that can process food efficiently may feed children before night. A group that can repair gear quickly may move before weather shifts. A group that can carry water or food, even in simple organic containers that rarely preserve gains range. Still, there is a danger in overpraising tools. They are not magic. A well-made spear cannot find animals that have left. A hearth cannot burn without fuel. Clothing cannot stop starvation. The human advantage lies in the relationship between tools, environment, and society. Stone fire, shelter, and clothing matter because people know when and how to use them, because groups cooperate around them, because knowledge accumulates rather than beginning again with every birth. Imagine a cold evening after a difficult day of foraging. At the edge of the firelight, someone strikes stone with controlled blows, producing flakes for tomorrow. Another person scrapes a hide that may become a cover against wind. Someone tends embers, feeding them slowly. A child watches hands move and learns without being told that this is how survival looks. There is no grand invention in that moment. There is maintenance. There is patience. There is continuity. Against extinction, continuity may be the greatest technology of all. The tools themselves are humble, but they hold back the dark in practical ways. They turn carcasses into meals, hides into warmth, plants into calories, wood into reach, fire into community, and knowledge into inheritance. If humanity passes through a bottleneck, it does so not as a naked species facing disaster with thought alone, but as a tool-carrying, fire-keeping teaching animal whose smallest objects preserve the possibility of tomorrow. If stone, fire, and food give humans a margin against extinction, society gives that margin shape. A lone human can be clever, but a group can remember. A lone human can find food, but a group can share risk. A lone human can survive a few hard days, but a community can keep children alive through years of uncertainty. In the deep past, when population numbers may have narrowed and landscapes became unreliable, the most important human technology may not have been held in the hand at all. It may have been the invisible web of obligation between people. The human body reveals this dependence. Human infants are born helpless, demanding care for years. Children learn slowly. They need food, warmth, protection, and teaching before they can contribute fully. This seems like a weakness, and in harsh conditions it certainly can be. But it also allows a long childhood, and long childhood allows learning. A young human can absorb enormous amounts of information, animal behavior, plant seasons, tool-making, social rules, danger signs, routes, stories, and skills that no instinct could provide alone. The price is dependence. The reward is culture. During a crisis shared, childcare may have mattered enormously. A mother struggling through hunger, injury, or cold cannot easily gather travel process food and protect a child alone. Help from fathers, grandparents, siblings, unrelated adults, and older children can change survival odds. This kind of cooperative breeding, broadly understood, is one of humanity's quiet strengths. Scholars still debate exactly how early and how extensively different forms of care operated, but the pattern of human life points toward deep cooperation. Children are not raised by isolated individuals. They are raised inside social worlds. Food sharing is equally central. In many foraging societies studied by anthropologists, large food sources are distributed beyond the person who obtains them. One hunter may fail while another succeeds. One gatherer may find roots while another returns empty-handed. Sharing smooths the harsh randomness of daily foraging. It does not remove conflict or inequality, and it should not be romanticized, but it creates resilience. A group in which food moves between households or kin lines can survive variability better than a group where every person bears hunger alone. This social sharing may become especially important when resources are unpredictable. A large animal kill produces more meat than one person can consume before it spoils, so distribution turns temporary abundance into social credit, alliance, and future support. Shellfish gathering may allow children and elders to contribute. Plant processing may involve many hands. Firewood collection, water, carrying tool repair, and watching infants all become part of the survival economy. The camp is not merely a place where individuals bring food. It is a system for converting uneven effort into group endurance. But cooperation within a band is only one layer. Humans may also survive by maintaining relationships beyond the immediate group. In a fragmented world, distant ties can be life-saving. Another band may know where rain has fallen. Another may have access to stone pigment shellmates or refuge. Seasonal gatherings can exchange not only goods but information. Who has died? Which valley is dry? Where animals have moved? Which route is dangerous? Which strangers can be trusted? Such networks are difficult to reconstruct, but the movement of materials across landscapes suggests that early humans were not always isolated in tiny sealed units. They lived in social geographies larger than a single camp. This matters for genetics as much as culture. Small isolated groups are vulnerable to inbreeding, demographic accidents, and local extinction. Networks allow people to move between groups, form partnerships, and keep populations connected. A few marriages across distance can preserve genetic diversity. A few visits across territories can preserve knowledge. If climate stress breaks these networks, populations narrow. If networks endure even weakly, they can help the species survive. The evidence remains incomplete, but the logic is powerful. The human line does not only pass through bodies, it passes through relationships. Symbolic behavior may have strengthened those relationships. Ochre ornaments, patterns, body marking, and shared rituals are often discussed as signs of modern human cognition, but they may also have practical social value. A marked body can signal identity. A bead can show belonging. A shared style can distinguish friend from stranger or link groups across distance. These interpretations must be cautious because meaning rarely fossilizes. Yet what survives in the record suggests that early humans were increasingly capable of using objects and markings to communicate more than immediate function. In a dangerous world, knowing who belongs to whom may be a survival tool. There is a lesser-known kind of resilience in storytelling itself. Before writing, memory must travel in speech, gesture, song, demonstration, and repeated performance. Stories can encode routes, danger seasons, animal habits, social rules, and warnings from past disasters. A tale about a dry valley may preserve practical geography. A remembered famine may shape future movement. A ritual gathering may renew alliances that later become critical. We cannot recover the words of people living 72,000 years ago, and no responsible account should pretend to. But humans are storytelling animals, and it is likely that spoken memory helped bind groups across time. Social life also manages conflict, and conflict can become deadly when resources shrink. A band under pressure faces disputes over food movement, mating leadership risk and obligations to the weak. Too much conflict can split a group below viable size. Too much rigidity can trap it in bad decisions. Human groups need ways to negotiate, persuade, shame, reconcile, and sometimes separate without destroying every future connection. These processes leave almost no direct archaeological trace, but their importance is hard to overstate. Survival is not only against nature, it is also against social breakdown. At the same time, outsiders can be both danger and salvation. A strange group approaching a water source may mean competition. It may also mean exchange marriage news or rescue. The ability to distinguish threat from opportunity is vital. Humans carry suspicion and curiosity together. In a bottleneck world, too much hostility isolates. Too much trust invites harm. Communities that manage this balance may survive better than those that cannot. No single explanation fully accounts for why some groups endured, but social flexibility likely mattered alongside environmental flexibility. Imagine a gathering during a rare season of plenty. Several small groups come together near a river coast or lake. Fires burn in clusters. People exchange stone shells, pigments, stories, partners, and news of distant places. Children see faces beyond their own band. Young adults form bonds that may move them across territories. Elders compare memories of rain animals and hard years. Nothing about this scene requires cities or agriculture. It is still fully prehistoric, mobile, and fragile. But such gatherings may create the wider human world from which survival draws strength. Then imagine those gatherings becoming rarer as climate worsens. A route dries out. A band fails to arrive. A familiar group is never seen again. The social map develops holes. Those absences matter. Each missing group means fewer partners, fewer stories, fewer routes, fewer options. The bottleneck may have been felt not as a statistic, but as loneliness spreading across the landscape. And still some ties hold. Someone remembers a coast. Someone carries a shell inland. Someone is welcome because a grandmother once knew their people. Someone shares food today and receives help years later. These small acts do not look like the foundations of history, but they may be exactly that. The survival of Homo sapiens is not only written in adaptation to climate, it is written in the ability to remain connected when the world encourages separation. The social survival code is therefore not a single rule. It is care-sharing memory identity exchange, teaching conflict management and trust stretched across uncertainty. It is the reason a child can live through a hungry season, the reason a tool tradition can pass through generations, the reason a small group can avoid becoming a dead end. If humanity nearly disappeared, then humanity survived not as isolated minds, but as communities holding one another against the dark. Humanity's survival feels less inevitable when another human stands beside it in the ancient dark. For most of our existence, Homo sapiens is not the only human form on Earth. The world holds cousins, rivals, neighbours, and strangers whose bodies and histories are close enough to ours to unsettle any simple idea of human uniqueness. Neanderthals live across Western Eurasia, adapted to cold landscapes and difficult hunting worlds. Denisovans, known mostly from fragments of bone and from DNA, occupy parts of Asia, in ways still only partly understood. Other populations may exist whose names we do not yet know, leaving traces in genomes but few fossils. The human family tree at 72,000 years ago is not a single trunk rising cleanly upward. It is a thicket. This matters because extinction is not theoretical. Other humans vanish. Their disappearance proves that intelligence, tools, fire, and social life are not guarantees. Neanderthals endure for hundreds of thousands of years. They survive glacial cycles, hunt large animals, make sophisticated tools, use fire care for injured individuals, and leave evidence of complex behavior. They are not failed brutes waiting to be replaced by superior modern humans. That older image has been steadily dismantled. What survives in the record suggests a capable human lineage deeply adapted to its world. And yet eventually Neanderthals disappear as a distinct population. The timing is later than the crisis around Toba, but the lesson reaches backward. If Neanderthals can vanish after such a long existence, Homo sapiens could have vanished too. Survival is not a medal awarded for intelligence. It is a relationship between population size, environment, reproduction, culture, chance, disease, competition, and time. A lineage can be strong and still vulnerable if its numbers are low, its groups are scattered, or its world changes faster than its adaptations can follow. The Neanderthal contrast forces humility into the story of our own endurance. Neanderthals are often described as cold adapted, and in broad terms that is true. Their bodies are generally stockier than ours, with proportions that may help conserve heat. They occupy regions where cold seasonal environments demand strength and knowledge. But cold adaptation does not mean easy survival. Ice Age Europe and Western Asia are harsh shifting places. Forests expand and retreat. Open steppe and woodland alternate. Large prey animals migrate. Glacial and interglacial pulses transform habitats. Neanderthals live well in these worlds for a very long time, but they may often exist in relatively small dispersed populations. That makes them vulnerable to demographic accidents, especially when conditions deteriorate. Homo sapiens, by contrast, may have developed a different kind of flexibility. Not necessarily better in every environment, and not instantly superior, but perhaps more capable of drawing on wide social networks, broader diets in some regions, symbolic communication, and rapid cultural exchange. These differences are debated carefully because the evidence is uneven, and older assumptions were often biased in favor of modern humans. Still, something about our lineage allows it to expand widely after surviving its own dangers. The question is not whether Homo sapiens is smarter in some simple way. The question is which combinations of traits matter when the world becomes unstable. There is also the unsettling fact of interbreeding. Modern humans outside Africa carry small amounts of Neanderthal ancestry, and some populations carry Denisovan ancestry as well. This means the story is not pure replacement, it is contact mixture, absorption, survival in fragments. Neanderthals disappear as a separate population, but part of them persists inside many living people. Denisovans, too, are not simply gone. Pieces of their inheritance remain, including variants that helped some later humans adapt to high-altitude life. A vanished human lineage can still leave gifts to the future. That detail changes the emotional shape of extinction. Disappearance does not always mean total erasure. Sometimes a people vanish as a distinct group while traces of them continue in descendants who no longer carry their name. But for the communities themselves, the loss would have been real. Their languages, if they had them in forms comparable to ours, are gone. Their local knowledge is gone. Their stories are gone. Their ways of understanding the world are gone. DNA preserves only a thin biological echo. It cannot restore a voice. When comparing Homo sapiens with Neanderthals, one must avoid turning the story into a contest with a predetermined winner. For long periods, Neanderthals are the successful humans of their regions. They know their landscapes. They possess tools suited to their needs. They hunt dangerous animals at close range. They survive injuries that imply care from others. They are not waiting for us to arrive. In some places, early Homo sapiens expansions may fail while Neanderthals continue. The eventual spread of our species is not a straight march of superiority, but a long uneven process shaped by climate, demography, contact and chance. The Denisovans make the picture even stranger because they are known so poorly in physical form and yet so clearly in genetic consequence. A finger bone teeth fragments from a Siberian cave later finds elsewhere, and DNA from living people reveal a population that once ranged widely enough to matter enormously. They remind us that the fossil record is incomplete in almost embarrassing ways. Entire human histories can remain hidden until a small bone in a cave or a sequence in a genome reveals them. Scholars still debate where Denisovans lived, how diverse they were, and how often they interacted with Homo sapiens and Neanderthals. The evidence remains incomplete, but it shows that the ancient world contained more kinds of humans than stone tools alone once suggested. This wider human world sharpens the meaning of the bottleneck. Homo sapiens survives a crisis or a series of crises, but survival does not yet mean dominance. Other humans still occupy large regions. Some are adapted to places our ancestors do not yet control. When modern humans later expand across Eurasia, they enter landscapes already known by others. There may be encounters at rivers, caves, hunting grounds, and migration routes. Some lead to exchange, some to mating, some perhaps to conflict or avoidance. Much is unknowable. But the genetic record proves that the boundaries between human groups were permeable at least sometimes. A lesser-known implication is that our survival may have been helped by contact with other humans. Interbreeding introduced genetic variants into expanding Homo sapiens populations. Some may have been neutral, some harmful, some useful in particular environments. Later humans did not carry only the inheritance of the African survivors. Outside Africa, they also carried fragments of relatives met along the way. In this sense, the human story after the bottleneck is not the triumph of one isolated lineage, but the gathering of remnants from several. Still, the comparison remains sobering. Neanderthals and Denisovans show that being human is not enough. Toolmaking is not enough. Fire is not enough. Long endurance is not enough. A lineage can survive ice ages and still disappear. A species can be rare for thousands of years, and then suddenly become the ancestor of billions. Deep time is full of reversals. The difference between persistence and disappearance may be small, delayed and visible only after the fact. Imagine the world from no one's privileged viewpoint. In Africa, Homo sapiens groups endure climate stress, perhaps volcanic aftermath, fragmentation, and hunger. In Eurasia, Neanderthals continue in their own territories, living with their own risks. Denisovan populations move through Asian landscapes that are still mostly shadows to us. None of them knows the future. None knows which lineages will leave descendants, which will vanish, which will blend into others. The earth holds several humanities at once, and all are mortal. The near extinction of Homo sapiens, then, is not an isolated drama. It belongs to a larger age of vulnerable humans. Our ancestors were not the chosen survivors of a story written in advance. They were one population among others, nearly broken by pressures we still struggle to reconstruct. Their cousins remind us how easily the ending could have changed. Had a few refuges failed, had social networks broken more completely, had climate shifted differently, had small surviving groups not recovered, Homo sapiens might have joined the silent branches of the human family. Another lineage might have endured longer, or none at all. That is the deeper contrast. The vanished humans make our own existence feel less like destiny and more like contingency. We are here because one branch survived its narrowing, then expanded, then encountered and absorbed traces of others, then kept moving. The world did not need us. The Earth had already seen many human experiments, most ended. Ours almost may have. After the deepest darkness, the human story does not suddenly become a march of conquest. There is no instant awakening, no single generation that steps out of crisis and begins to take the world. Recovery in deep time is slow, uneven, and almost invisible while it is happening. A small group becomes two. A familiar valley is used again. A coastline supports more children than it did before. A route once too dry becomes passable after rains return. People who have been isolated begin to meet others more often. The line that narrowed begins quietly to widen. This widening matters as much as the crisis itself. A species can survive a bottleneck and still remain vulnerable for thousands of years. Low numbers mean every local disaster matters. A disease a failed season, a conflict a flood, or the death of key adults can erase a small community. Recovery requires not only births but connection. Groups must grow large enough to exchange partners, preserve knowledge, and move into new landscapes without losing contact completely. What survives in the record suggests that Homo sapiens did not recover by staying still. Movement becomes part of survival. Across Africa, changing climates open and close corridors. In wetter periods, grasslands spread into places that had been barriers. Rivers flow more strongly. Lakes expand. Animals move and humans follow. In drier periods, deserts harden again, separating populations and forcing people toward refuges. This rhythm of opening and closing may have shaped human expansion for tens of thousands of years. Migration is not a single heroic departure. It is repeated testing of edges. A group moves farther along. A river returns to a coast, follows herds into new country, or crosses a corridor that only exists for a few generations. Eventually, some Homo sapiens populations move beyond Africa in ways that lead to lasting settlement across Eurasia and later the rest of the world. Earlier excursions may have happened before, but not all expansions leave descendants or enduring archaeological traces. The successful later dispersals are not simply acts of boldness. They depend on timing, climate, geography, population, pressure, technology, and social networks. A route out of Africa may be possible in one period and punishing in another. A coastline may guide movement. A green corridor through what is now desert may invite passage. A narrow crossing may become reachable because sea levels are lower. The evidence remains incomplete, but the pattern is clear enough. Humans expand when landscapes allow and when communities are ready to risk the unknown. The Arabian Peninsula may have been one of these shifting gateways. Today much of it is arid, but in wetter phases it held lakes, rivers, grasslands, and animals that could support human movement. Stone tools found in such regions suggest that ancient humans entered and used these landscapes during favourable windows. When conditions dried, some populations may have retreated, died out, or moved onward. The peninsula was not merely an empty bridge. It was a changing world in its own right, sometimes hospitable, sometimes deadly. To cross it required following opportunity before it vanished. Coastal routes may have offered another path. Lower sea levels exposed shorelines now drowned, potentially creating chains of resources along the edges of the Indian Ocean. Shellfish, fish, coastal plants, birds, and freshwater sources could support movement if groups understood the shore. This idea is attractive because coastal foraging may have provided reliable food across long distances, but it is difficult to prove in detail because many ancient coastal sites now lie underwater. The sea has hidden much of the evidence. Scholars still debate how important coastal migration was compared with inland routes, and no single explanation fully accounts for the spread. The truth may involve both at different times and places, As humans move, they carry more than bodies. They carry techniques, social habits, memory ornaments, fire practices, tool traditions, and ways of reading unfamiliar landscapes. A group entering new territory faces a double challenge. It must survive the environment and interpret it quickly enough to avoid fatal mistakes. Which plants are edible? Which animals are dangerous? Where does water remain in dry seasons? What stone can be worked? What shelters are safe? In familiar land, answers are inherited. In new land, answers must be learned, borrowed, or discovered through risk. Contact with other human lineages adds another layer. As Homo sapiens expands into Eurasia, it encounters Neanderthals and Denisovan-related populations. These encounters are not fully visible, but their genetic consequences remain. Some meetings lead to interbreeding, leaving traces in later people. This means migration after the bottleneck is not a clean replacement wave moving through empty country. It is a complicated human world of overlap, mixture, avoidance, and perhaps competition. The ancient map is populated and Homo sapiens enters it as both newcomer and survivor. One surprising detail is that expansion itself can create new bottlenecks. When a small group leaves a larger population and settles elsewhere, it carries only part of the genetic diversity of its source. This founder effect can shape all later descendants. Each movement into a new region may narrow variation again even as the total number of humans grows. The species expands geographically, while certain populations become genetically filtered. That is why the genetic story of humanity contains multiple layers, ancient African structure, possible crisis-related reductions, migrations out of Africa, founder effects, and later mixing with other humans. The emotional image of migration is often a line on a map, but real movement is messier. People do not move like arrows. They pause, turn back, split merge, follow animals, avoid enemies, return to known places and occupy landscapes season by season. A child born during a migration may grow up knowing only the new land. An elder may carry memories of a coast or valley no younger person has seen. A group may spend generations along one corridor before another branch moves farther. The spread of Homo sapiens is not a single journey. It is a slow unfolding of many local decisions. And still something changes after the bottleneck. The human presence becomes harder to erase. Populations grow, networks widen, tool traditions diversify, symbolic objects become more visible in some regions. Eventually, cave art elaborate burials, long-distance exchange, tailored clothing, watercraft, and specialized hunting technologies appear in different places and times. These later developments should not be projected backward too neatly, but they show the direction of the widening line. A species that once may have survived in scattered refuges begins to occupy nearly every kind of habitat the planet offers. This expansion does not mean the crisis is forgotten in any conscious sense. No oral memory can carry exact events across 70,000 years with reliable detail, but the consequences remain. Surviving populations carry the genetic traces of narrowness. Cultural flexibility honed under pressure becomes part of humanity's strength. The habit of movement, exchange, experimentation, and adaptation continues. The species that emerges from the dangerous period is not untouched by it. It is shaped by having passed through a world where staying alive required options. Imagine a group standing at the edge of a greener corridor after generations of constraint. Ahead lies country known only by rumor, animal movement, or distant memory. Behind lies a refuge that has kept people alive but may no longer be enough for everyone. They do not think of expansion as destiny. They think of food, partners, safety, children, and the pressure of numbers. They move because the world opens, because need pushes, because curiosity pulls, because others have gone ahead, because remaining is not always safer than leaving. From those movements, the later human world begins to take shape, not quickly, not cleanly, but steadily enough that the narrow line becomes a branching one again. The species that almost wasn't begins to appear in deserts, forests, coasts, mountains, and cold northern lands. Each new landscape tests it. Each surviving group adds another thread. And somewhere behind them, all hidden under ash climate stress, lost camps and drowned shores, remains the memory of a time when there were far fewer threads to lose. The deepest echoes of the near extinction story are not found only in caves, ash layers, or ancient shorelines. They are carried quietly in living bodies. Every person alive today contains a record shaped by countless births that happened, countless births that did not, migrations that succeeded, groups that vanished, and meetings between human lineages that once seemed separate. DNA is not a complete history, and it is not a diary of experience, but it preserves patterns that no stone tool can show. It reveals that the human past was not a smooth expansion from a single strong beginning. It was narrow-braided, interrupted, and full of loss. When scientists study human genetic diversity, they find signs of ancient population structure and ancient reduction. The details are complex, and scholars still debate how best to interpret them, but the general picture is humbling. Humans today are remarkably similar genetically compared with many species spread across large ranges. This does not mean humans are identical, and it does not erase the meaningful diversity that exists among populations. It means that in evolutionary terms, the surviving human line passed through filters. Some variation that once existed did not make it into the present. Some branches of Homo sapiens left few or no descendants. The future did not inherit everything the past contained. This loss is easiest to misunderstand when imagined as a single number. Popular accounts sometimes speak as if humanity fell to a tiny handful and then rebounded neatly. The actual evidence is less theatrical and more interesting. Genetic bottlenecks can reflect many processes: long-term small population sizes, fragmentation across Africa, expansions from only some source populations, later migrations by small founder groups, and environmental crises that struck unevenly. The evidence remains incomplete, and no single explanation fully accounts for the patterns. But the signal of narrowness is real enough to make the human story feel precarious. Founder effects are one part of this pattern. When a small group leaves a larger population and settles elsewhere, its descendants carry only a fraction of the genetic variation found in the source. If later groups move again, the filtering repeats. This is one reason populations farther along certain migration routes may carry less variation than populations closer to the deeper African roots of Homo sapiens. It does not mean those later populations are less human or less complex. It means their ancestors passed through smaller moving gates. Geography, chance, and survival shaped the genetic map. Ancient DNA has added even stranger layers. For a long time, Neanderthals and Denisovans were known mainly through bones and tools. Then their genomes revealed that modern humans did not simply replace them from a distance. There was contact. There was interbreeding. Many people outside Africa carry Neanderthal ancestry. Some populations, especially in parts of Oceania and Asia, carry Denisovan ancestry. These fragments are small but profound. They mean that vanished humans are not entirely outside us. Parts of them remain folded into the living human genome. Some inherited variants may have influenced immunity, skin biology, metabolism, or adaptation to particular environments, though each claim must be treated carefully. The famous high-altitude adaptation in some Tibetan populations appears linked to Denisovan-related ancestry, a remarkable example of a vanished lineage helping later humans live where oxygen is thin. Other archaic variants may have been neutral or even harmful, and were reduced by natural selection over time. The point is not that ancient interbreeding was always beneficial. The point is that the human genome is a palimpsest written over older human encounters. This makes the survival of Homo sapiens less pure and more moving. The species that emerges from the bottleneck and later expands is not sealed off from other humans. It absorbs traces. It is changed by contact. Its future is partly built from lineages that later disappear. In a biological sense, some of the dead remain useful to the living. In a human sense, this is both beautiful and sad because genes preserve only fragments. They cannot preserve the faces, gestures, fears, or memories of the people who carried them first. DNA also reveals ghost populations groups inferred from genetic patterns, even when no clear fossils have been found. These ghost lineages remind us how incomplete the physical record is. A population can shape ancestry, and yet remain almost invisible archaeologically. A cave may never be discovered. Bones may decay in acidic soils. Coastal sites may drown. Tools may be indistinguishable from those of neighbours. Whole human worlds may leave only a statistical shadow. What survives in the record suggests that the ancient human landscape was more complex than any simple map can show. The bottleneck story then becomes less like a single narrow bridge and more like a river delta seen after most channels have dried. Some channels once carried life and now leave faint marks. Others fed into larger streams. Some disappeared before reaching the present. Modern humanity flows from surviving channels, but the dry ones were real. They held people. They held possibilities. The fact that they are gone does not make them irrelevant. Their disappearance shaped what remained. There is a surprising emotional force in this. Every person alive is descended from survivors, but not from all survivors equally, and not from all people who once lived. The ancestors who contributed to the present were those whose children had children, whose lineages escaped disease, hunger, isolation, conflict, and chance for generation after generation. This is not a story of superior individuals in any simple way. Much of ancestry is luck repeated across time. A child survives a fever. A group finds water. A migration route opens. A stranger becomes a mate rather than an enemy. A volcanic winter is endured in one refuge but not another. After enough generations, these accidents become genealogy. The genetic echo also warns against imagining the past as a ladder leading toward us. Evolution does not aim at modern humanity. It preserves what survives long enough to reproduce under changing conditions. Many traits that later seem important may have begun as local adaptations, social habits, or neutral variations. Human creativity, language, cooperation, and technology all matter, but they operated inside a world of chance. The bottleneck reminds us that a brilliant species can still be filtered by drought, ash, disease, distance, and birth rates. And yet from that filtering came expansion. The narrowness did not end the story. It shaped the people who carried it forward. Modern humans inherited not only genes, but tendencies toward movement, social learning, flexible diets, and cultural accumulation. These are not all reducible to DNA, but population history and culture influence one another. Small groups under pressure may innovate, conserve, borrow, or lose knowledge. Later expansion spreads some traditions and not others. In this way, the genetic and cultural records are separate but intertwined like two shadows cast by the same ancient fire. No genome can tell us exactly what it felt like when a group failed or survived. It cannot show the last night of a camp, the first child born after a famine, or the moment strangers exchanged food instead of violence. But it can tell us that our existence passed through constraints. It can tell us that the human family was once smaller, more fragmented and more vulnerable than the modern world suggests. It can tell us that some ancient encounters left marks still present in blood cells and immune responses. It can tell us that extinction and survival are not always clean opposites. Sometimes they mingle. So the echo in our DNA is not a simple answer to the mystery of 72,000 years ago. It is a reminder that the mystery has consequences. The crisis did not vanish when the skies cleared or the climate shifted again. It became part of the long inheritance of humanity carried silently through migrations, births, mixtures and recoveries. Every modern city, every language, every face in a crowd stands on the far side of that narrowing. Inside the ordinary human body is a trace of a time when the ordinary human future was anything but certain. The closer one looks at the near-extinction story, the less it resembles a single locked door with one key. Toba is enormous, dramatic and timed closely enough to demand attention. The genetic bottleneck is real enough in broad outline to make the human past feel narrow. Climate instability is not background noise, but a constant pressure shaping where people can live and how many children survive. Yet when these clues are placed together, they do not form one perfectly clean explanation. They form a field of evidence with gaps between the stones. Scholars still debate how much weight each clue should carry, and the debate itself may be the most honest shape of the story. The simplest version says that Toba erupts. The sky darkens, volcanic winter, follows ecosystems collapse, and Homo sapiens nearly disappears. It has the power of a myth, because it gives the crisis a face: one mountain, one blast, one shadow over the world. But the archaeological record resists that simplicity. Some regions show signs of human continuity across the period. Stone tool traditions do not always vanish where the ash appears. Human groups may have endured in places that should have suffered if the most extreme model were true. This does not mean the eruption was harmless. It means catastrophe did not act evenly, and humans were not equally vulnerable everywhere. Another explanation places less emphasis on one eruption and more on long-term climate instability. In this view, Homo sapiens passes through repeated pressures, drying landscapes, shifting rainfall, colder phases, changing coastlines, and fragmented habitats. Populations shrink in some regions, survive in refuges, reconnect when climates improve, and separate again when conditions worsen. The bottleneck becomes not a single blow, but a slow tightening. This model fits the messy nature of deep time. It also makes the story harder to dramatize because 1,000 hard seasons leave fewer obvious scars than one volcanic ash layer. But slow disaster can be just as deadly as sudden disaster. Disease is another possibility, though it is harder to prove. Small, stressed populations can be vulnerable to infection, especially if groups gather around limited water or food sources. Pathogens leave poor traces from such deep time, and no responsible account can claim a specific epidemic caused the bottleneck. Still, disease likely shaped survival in ways the record barely captures. A fever moving through a small band could erase crucial adults. A sick season could reduce births. Malnutrition could make ordinary infections deadly. The evidence remains incomplete, but biology does not pause during climate crisis. Ecological competition may have mattered too. Humans shared landscapes with predators' prey, and in some regions other human lineages. If changing climates compressed life into fewer refuges, competition around water, shelter and food could intensify. Groups that once avoided one another may have been forced into contact. Some contacts could bring exchange and mating, others could bring conflict. Archaeology rarely preserves the full social consequences of crowding, but the logic is clear: when usable land shrinks, relationships change. Survival becomes political long before states exist. There is also the possibility that the bottleneck signal partly reflects population structure rather than collapse. Africa may have held many separated Homo sapiens groups, some connected, occasionally others isolated for long periods. Later expansions may have drawn descendants mainly from a subset of those groups. If so, modern DNA could appear narrowed not because almost everyone died at once, but because only some ancient populations became major ancestors of later humanity. This does not make the past less tragic. It means disappearance may have happened through exclusion from the future rather than immediate extinction. No single explanation fully accounts for this because the records measure different things. Volcanic ash records eruption. Climate proxies record environmental change. Archaeological sites record human behavior where preservation happened. DNA records ancestry among survivors, not among everyone who lived. Each source is powerful, but each is partial. The ash can say the eruption happened. It cannot alone say how many children died in southern Africa. DNA can suggest narrowing. It cannot name the storm drought or social fracture behind it. Stone tools can show continuity. They cannot prove a community did not suffer hunger or lose half its members. This is the central challenge of deep human history. The most important events may leave the least direct evidence. A population decline can happen without mass graves. A culture can vanish without ruins. A migration can leave no clear trail if its camps are now underwater or eroded. A famine can pass through bodies and leave only fewer descendants. The absence of evidence is not evidence of comfort, but neither can absence be filled with invention. The line between caution and imagination must be held carefully. Fringe theories often rush into that gap. Some turn Toba into an unsupported global extinction drama with numbers too precise for the evidence. Others dismiss environmental crisis too easily because humans survived in some places. Both extremes flatten the past. The stronger view is more patient. Toba was real and enormous. Climate instability was real and prolonged. Genetic narrowing is a meaningful clue. Human resilience is visible in several regions, and the exact relationship among these facts remains debated. The truth may not be one cause, but a convergence. A useful way to imagine it is not a single spear thrust, but a net tightening. Climate stress pulls one strand. Fragmented populations pull another. Toba adds a sudden weight. Food insecurity tightens the mesh. Isolation reduces options. Disease, conflict, and chance move through the gaps. Some groups slip free because they live near coasts, rivers, wetlands, or highlands. Others are caught. The species survives not because the net is weak, but because it does not tighten everywhere at once. That unevenness may be the key to everything. Global catastrophe stories often imagine the same disaster falling on all people equally. But real landscapes are patchy. Rain falls here and fails there. Ash is thick here and absent there. A valley shelters life while a plain empties. A coast remains productive while inland herds decline. One group has allies, another is isolated. One remembers famine foods, another has lost elders who knew them. In such a world, survival is distributed. Humanity does not need every group to endure. It needs enough groups in enough places to keep the line alive. This makes the near-extinction story both less simple and more profound. It is not only about whether humans almost died after one eruption. It is about how close survival can come to failure when many pressures overlap. A species can be reduced not by one enemy, but by a sequence of ordinary vulnerabilities pushed beyond their limits. Hunger, cold distance, poor birth rates, lost knowledge, failed alliances, and ecological change can together do what none could do alone. The mystery remains because the evidence cannot yet close every gap. New genetic methods may refine the timing of population changes. New archaeological discoveries may reveal more continuity or more disruption. Underwater research may someday recover drowned coastal sites that change the picture dramatically. Better climate models may sharpen estimates of Toba's aftermath. The story is not frozen. It continues to be revised as fragments emerge from caves, sediments, genomes, and submerged landscapes. But uncertainty does not weaken the central lesson. Around this period, humanity appears to pass through danger, deep enough to shape its future. Whether Toba was the decisive blow or one force among many, whether the bottleneck was sharp or prolonged, whether the surviving population was smaller than we imagine or simply more fragmented than we once thought, the result is the same. In human terms, the future narrowed. Many possibilities ended, some endured, and perhaps that is the most accurate answer to what really happened. Not a neat verdict, but a convergence of pressures acting on a rare, scattered, adaptable species. The Earth changed. The sky may have dimmed, habitats shifted, populations broke apart, some communities found refuge, some did not. The line thinned, but it did not snap. From that incomplete survival came the later human world, carrying in its bones and blood the memory of a crisis whose full shape still hides just beyond the reach of proof. The astonishing thing about humanity is not that it became powerful, it is that it first remained possible. Before cities, before writing, before ships, before agriculture, before any empire could rise or fall, there had to be enough people alive in enough places with enough memory intact for the human story to continue. Around 72,000 years ago, that condition may have come under severe threat. The species that would one day measure galaxies and split atoms may have survived because small groups found shellfish at the right tide, remembered hidden water, kept fire alive, shared food, and carried children through landscapes that had become less forgiving. The phrase humans almost went extinct can sound like a single cliff edge, but the deeper truth is more haunting. Extinction often approaches as narrowing. Fewer groups, fewer roots, fewer partners, fewer elders with memory, fewer children surviving to adulthood. Fewer chances to recover after one bad season becomes 3. The world does not need to kill everyone at once. It only needs to make recovery slower than loss. What survives in the record suggests that Homo sapiens came through a period when this balance may have been dangerously close, and yet the line continued. Not because humans were destined to rule the earth, and not because they were untouched by catastrophe, but because they were flexible enough, social enough, and fortunate enough to endure. Some populations vanished, some refugees held, some knowledge was lost, some knowledge passed on. Later, when climates shifted and routes opened, surviving groups moved, met others mixed with other human lineages, and began the long expansion that would eventually carry their descendants across the planet. This is the quiet legacy of that ancient crisis. Every later human achievement rests on a survival story no one at the time could understand. The people who lived through it did not know they were preserving a species. They did not know their fires would lead to languages, monuments, music, science, or history. They knew hunger, weather, kinship, danger, and the next day's walk. Their victory was not glory, it was continuation. The species that almost wasn't became the species that remembers, even if imperfectly. We remember through DNA, through stone, through ash, through shells, through fragments pulled from caves and lake beds. The evidence remains incomplete, and scholars still debate the details, but the shape of the lesson is clear. Humanity is not built on inevitability. It is built on survival through uncertainty. And so the story ends not with a roar, but with a small fire under an ancient sky. Around it sit people whose names are gone, whose voices are gone, whose faces cannot be recovered. The world beyond the fire is colder than it should be, or drier, or simply less reliable than memory promised. Somewhere a child sleeps. Somewhere an elder watches the dark. Somewhere a tool waits beside a hand. They do not know that time will widen after them. They do not know that their descendants will cross oceans, paint animals on cave walls, bury the dead with flowers and ochre raise stones toward the sky, plant seeds, build cities, lose cities, invent gods, question gods, map the stars, and wonder where they came from. They do not know that one day people will look back across 70,000 years and realize how thin the line once was. All they know is that the fire must last until morning. That may be the most human image in the whole story. Not conquest, not certainty, not destiny. Just warmth held against darkness, knowledge passed from one body to another, and life continuing because enough people refused or simply managed to disappear. The earth has changed many times since then. Seas have risen over old shores, rivers have shifted, ash has turned to soil, bones have dissolved, camps have vanished beneath forests, farms, towns, and waves. But somewhere inside the living human world the ancient narrowing remains. It is there in the shared ancestry of billions, in our restlessness, in our dependence on one another, in the strange fact that every ordinary breath belongs to a species that once may have come close to silence. The final image is not of extinction, but of distance. A group walking at dawn, leaving faint tracks in cooling ash, or pale dust moving toward water, toward food, toward uncertainty. Behind them the night closes over the camp they have left. Ahead of them the world is still dangerous, but they are moving, and because they are moving the story continues.